Hey everybody, welcome back to part 2. For this part we're going to go over the accelerometer, which I have right here. So here's the accelerometer. We're going to go about how you connect this to the board, and we're going to talk about what this sensor does, what it can measure, and go over how it measures it and what you can do with it. So with that out of the way, let's just dive right in. So for this next part, I want to talk about what an accelerometer is and more specifically what it measures. Acceleration is the rate of change of the velocity. So if you look at this graph here, you can see the velocity, and the velocity is just the speed of the aircraft. So it starts off going very slow, and then at this point here, it's going at a much faster rate. So basically 0 to however fast it's going here. But the acceleration is the rate of change of that velocity. So the velocity starts slow, it gets higher, but the actual acceleration here is a constant acceleration. And that's due to a constant force on the plane. So the constant force causes a constant acceleration, which creates a changing velocity for this example. And the accelerometer itself measures acceleration in 3 dimensions. We'll get into more to that as we get into what the gyroscope is. So how does the sensor measure the acceleration? And so basically what's going on is if you look at this graph over here, this is a very simplified approach, and it's using much smaller measuring tools, but using some physics equations that you may or may not be familiar with, but springs have a constant to them that kind of define how much force it takes to make them stretch. And so if you measure that, if you know the mass of this ball that's hanging, you can get the force that's being applied to it by multiplying the distance of how far it's hanging with the spring constant, which in turn, using F equals ma, or force equals mass times acceleration, you can divide that value by the mass to get the acceleration. So this is the general idea of how it works, but it's a lot more accurate and complex in the actual sensor itself. And each of these sensors are actually in your smartphones too. It's why like certain games will work with tilting and things like that. So next we'll talk about the gyroscope. So to help explain what a gyroscope measures in regards to what an accelerometer measures, if we look at this pencil and think of it as an object in 3D space, which it is, the acceleration measures the rate of change of the movement in 3D space. So in 3 dimensions just means that I can move it horizontally, I can move it vertically, but then I can also move it closer and further from me, or depth. But the gyroscope measures the orientation of the pencil in this case. So the orientation is just if I tilt the pencil up but I maintain the same position, the pencil is still moving, but it's still got the same relative position in space. It's not moving like this, it's not moving like this, it's just changing what direction it's pointing. And this also has three dimensions. It can rotate up and down, it can rotate left and right, and they can also spin. It's hard to see with this pencil, but so that's kind of what the gyroscope is aiming to measure, is the orientation, where the pencil is pointing. So now that we went over what an accelerometer and gyroscope, what they are, we're going to go over how you can actually connect them to the board and get readings from them. Connecting it to the board is very simple since we have our Grove shield attached to the board. So you're going to want to take your accelerometer, and it should have came with a little wire connector here. So all you have to do is plug in the wire connector into the accelerometer. And that should just plug right in. And then you're going to want to take the other end and plug it into the board. And I'll show a close-up here of where you want to do that. So once you have them connected, you should have something that looks like this here, showing it all together. And I like to attach or just tape down both of them to a steady surface. I just have some foam board here, So if they're both attached together, that means that when I move the accelerometer or tilt it or anything like that, the board moves with it. So that means they're attached together. I'll just apply a little tape, I'll show a little picture, just so that they're attached together, so that way any movement I apply to the board is applied to the sensor. Alright, so now that we have the Arduino connected to the accelerometer, let's go over what we need for the software side of things. So make sure that your board is connected to the computer through the USB cable, and then we'll just look at the code here. So this code is available in the description below, and basically you can just copy this code and create a new, and then go to new, and then make a new file here, and you can just delete all this and then paste in the code in the description, so you have this file, and then just make sure you save it as well. So then you'll have what I have here. We'll go over what you need for this code. One of the things that you do need is you need a library that doesn't come with the Arduino basic standard libraries, and what this library is it does most of the calculations and communication with the accelerometer for you, and it reads it in and lets you get nice values out of the accelerometer. So that part is very nice. So how you get this is you just copy this here. So LSM6DS3 is the name of the library, and then if you go to Sketch and you go to Include Library, and then you go to Manage Libraries. So that'll pop up with the library manager with a list of different libraries, and then you just paste in or type in LSM6DS3 into the search bar, and the one you want is the second library right here, the one by Seed Studio. And then there should be a install button right where my update button is, so like up here, install, but this one here should have install here, so then you click install, it'll take a second, and install that, and then you can close. So that's for the accelerometer. We won't go over these libraries. The servo one is for the servos, but these should all be included automatically. And so looking at some of the code, a lot of this stuff is set up for the servo, so we won't go over it right now. But what we are going to look at is this reading of the sensor. So what this is doing is these print functions are just printing to the log, and we'll show you what that is in a second. But what we're printing basically is information from the accelerometer. So this function here, read float accel x, gets the x value of the acceleration and then prints it out with this print function. So, and then we do that with the y value and the z value. So we mentioned before, we're working with 3 dimensions, so we have 3 different values, x, y, and z, for the different dimensions. And then the rest of this code is for the servo stuff, so we'll get to that in the next one. But for these here, how you read these is, first you want to upload this code, so make sure you hit upload, make sure your board is connected, and then make sure everything goes right up here, and you should get a done uploading thing. If something goes wrong with the libraries, you may have to install some libraries, but these should all be included. So then you go to tools. So now, since it's uploaded, it's automatically looping through this loop function on the board. So if we go to tools and we go to serial monitor, this is where it's printing. And so now you can see it's printing these values. So if I stop the auto scroll here, you can see that it's printing. You can ignore this first one for now, but you can see that it's printing out the x acceleration value, y acceleration, and z acceleration. And it's printing out these values in G's, which is the gravitational constant of 9.8 meters per second squared. So this is 0, 9.8 meters per second squared, this is 0, approximately 0, and then this one has 1. So it's 1 times 9.8 meters per second squared. And so this might throw you off because right now my board is just sitting on my table. Hopefully yours is probably 2, but you're still going to get a reading of 1 times or 1.0 for this direction. And the reason for this is because of the way acceleration is measured inside the chip. It's measuring acceleration how we talked about before, using a spring and mass like system. It's not quite that, but it's similar. And so the way it measures is actually always being affected by gravity, because gravity is always affecting that mass on the spring. So it always thinks that it's accelerating at 9.8 meters per second squared. It's basically the gist of it. So that is the main point here. So this z value is going to be 1 unless, and let's go to auto scroll again. So you'll notice it's at 1 here, but if I tilt the board, that value changes. And that's because when you tilt the board, the gravitational force isn't straight down anymore, so it's less of a force on the mass. And so we can actually use this information to get an angle, and we'll talk about that in the next video. But for now, you can experiment with this sensor. Now since we got it working, if you try like shifting the board from left to right really quickly, you should see one of the values. Like you can see the y1 value here. If I move it left and right, you can see the acceleration increase really quickly and then decrease really quickly, and then up and down as well. So that's basically it for the accelerometer on its own. It's just measuring these values, and you can see it being printed in real time, which is pretty cool. So now, since we've gotten the software set up and the hardware set up, you should have something that looks like this, that reads inputs from the acceleration that you're applying to it, and outputs it to the computer. So that's going to conclude this video, and in the next video we're going to cover how to connect a servo to this machine and then read inputs from the accelerometer and output values to the servo so that they can communicate with each other. But in the meantime, I encourage you to explore what values you can get from the accelerometer without breaking it, of course. But yeah, so just go with that, and then in the next video we'll cover the servos. So thanks for watching.